I've made a decision. It's a very important decision. And it's a decision I think you'll all like very much, which is that we're going to do a short session before breaking for the evening. The reason for this, so the plan that I was thinking of doing was to do the same thing that we've been doing for offices, right? Be able to add an office, edit an office, delete, and so on, and be able to view the list of offices from within the view for a company, right? The issue there is that we're going to run into bugs, and these are not just trivial bugs. These are really like of pretty fundamental importance. So I want to make sure that we don't do that at the end of a day. I want to make sure we're all fresh and have enough time to like really look at them in good detail. So we're not going to do that exercise now. We're going to do that in the morning tomorrow. So basically tomorrow morning we're going to be doing the same sort of stuff we've been doing, adding views, adding controllers, and then we're going to take as much time as we need to debug the what's going to appear to be very strange issues. Right? Hibernate is going to start throwing all kinds of exceptions at us that we haven't seen before, and I really want to take enough time in the morning to be able to do that. So what we're going to do instead, and this won't take us a whole lot of time, but what I want to do instead is talk more just at a high level about these complex mappings, right? We've seen, basically we've got this little to-do here that says we've got this weird looking join table, right? If we go and look at our DB, if we go and look at our DB, we've got this company office join table, and I mean it makes sense that we would have such a table, right? Because companies and offices are joined, but it's got, I don't know, I don't like, since I'm being very particular about my database schema, I want to kind of take some control over the schema, right? I want to go over how we would specify the names of these columns, for example, right? Because company with a big C and offices plural, like those don't follow our column naming conventions. Like everything else that we have basically seems to be pretty good, right? But not those. So the first thing that we're going to do is figure out how to fix this join table just to make the columns look decent. But then the second thing that we're going to do is kind of like we talked about, the join table isn't even really necessary. So we'll talk about why that is again, and figure out how to eliminate the join table altogether. Okay. All right. First things first. Let's go back to that Hibernate annotation documentation, right? Again, you guys all have this in that README file now, so you should be able to refer back to it. You can Google for it. It's if you just Google for Hibernate annotations, you'll find this link. And I'm going to go back up to the table of contents here and look for mapping, entity, associations, and relationships. And this will sort of formalize a little bit some of the stuff that we talked about already, like one-to-one, for example. Right? All right, I guess this is a Wizard of Oz reference, maybe? A body has a heart. And there's a one-to-one relationship between bodies and hearts, I suppose. Right? Remember this cascade. What does cascade do? Yeah, so anytime, for example, anytime a body is updated, it's going to make sure that any changes that were made to the heart object will also be persisted, right? If you delete a body, that heart will be deleted, it won't be left dangling, right? So this is sort of our database version of garbage collection in a sense, right? So that's what that cascade stuff is all about. How about this one? Customer and passport. All right, our domain model is customers and passports now. We could do the same thing with bodies and hearts, I suppose. Right. Our customer has a passport, So there's one-to-one mapping here. And we're specifying the name of the column. This is new. What would it normally be? When we had our one-to-one mapping for what was it? Persons and addresses or whatever. What did the foreign key, the join column, look like?
Address underscore ID.
Yeah, it was address underscore ID. Well, using the join column annotation, we can specify the name of the column if we want to. So,
Case sensitive.
Yeah, it is case sensitive.
They put it on top of get.
Hmm?
The annotation is on top of get.
Oh, yeah, I guess that's worth mentioning. We've been annotating our fields. You can annotate the getters instead. Same thing. Yeah. Yeah, no difference.
What do you mean by annotating the getters?
Hamish pointed out that this is actually annotating like the getter method, not the name of the field. Again, same.
So it's one or the other, or?
Yeah, one or the other. Yeah. Okay, so point being, we can specify the name of our columns if we want to, and that's important. We'll use that soon. Right. And then another thing that we haven't seen yet is this mapped by, right? So customer has a passport. A passport, we want to be able to get the owner of a passport. But we don't want a foreign key in the passport table, right? It'd be sort of redundant to have the customer table has a foreign key to the passport, and the passport table, has a foreign key back to the customer. That would be redundant, right? Right. Okay. Right. So instead, what we can say is that this is a one-to-one relationship, and it is mapped by the passport field of the owner. How would we do this? Let's do an example in our code. Oops. So, well, see, this becomes a little bit difficult. Yeah, we can't actually we can't actually do it like this because addresses. Yeah, I was gonna say, the address should have a get person, like who's the person at that address, but
We have offices.
we also have offices, and they don't have anything, like they don't have a good common superclass. I mean, base entity is their common superclass, but that's pretty crappy. So let's just use this example, right? Okay, so once again, what does the database schema for customer look like?
Foreign key references.
Yeah, so it's going to probably have an ID, maybe a name, and some stuff. And the important thing is that it's going to have a column called passport underscore FK, or if we didn't specify that, it'd just be passport ID, right? That references a particular passport, right? Now, what does the passport table look like? Should a passport have a duplicate column? Like should the passport table have a customer column?
Customer ID.
You think it should?
Yeah.
Not the ID, the customer itself.
Customer doesn't have the passport ID, right?
Customer does have the passport ID. That's what we're saying here. We've called it passport
If
FK.
the customer is dependent on the passport.
We're saying that the customer is the owning side of the relationship. So we're going to talk about the owning side and the non-owning side.
Right. So if the customer is the owner of the passport, then the ID should be in the passport table.
The
Right.
customer cannot exist alone, right?
The customer cannot exist alone. The customer requires a passport. So there should be a passport ID
In the customer.
in the customer
passport
table.
cannot exist alone, right?
Yeah, right. Yeah. So we're also saying that the passport can't exist alone. But And I think I understand what you're saying, right? Like we also want a constraint that says that we want a database constraint that says that. Let's say we don't care about that constraint. Let's see. Yeah. Right. So in that case, basically, if we don't want that that other thing to exist, we would specify that it's one-to-one mapping, but we would say that it's mapped by the pass. So this is a really weird notation. Sorry, it's mapped by the passport field.
That's why you then check the get passport method.
Yeah, this is so when we say passport here, it corresponds to this get passport.
Yeah, and you get the column name.
And that's where we get the column name from. Yeah, exactly. Yeah. So this is the inverse or the non-owning side of the relationship. So we say mapped by. Right. All right. So that's inverse relationships for one-to-one mappings. It's not that important for us. We're not going to use that, but we are going to use the inverse side of a one-to-many mapping.
So the passport table would have an ID?
Yeah, it should have an ID. Yeah, they sort of left that out in the example here.
There's an assumption that there's a base entity class.
Yeah. There's some assumption here that passport has some.
So what if you don't put mapped by? Even then it should work, right?
If you don't put mapped by, then it will create a foreign key column pointing back.
Correct. So in this case it won't.
In this case, it won't. Yeah.
So you
So
don't have a constraint, but you can get back the object. Is that what the idea is?
I'm sorry.
So you don't want the constraint to be there. So the passport can exist alone.
Yeah.
But you can still get the contact object.
Yes.
Oh.
Yeah. Okay. Another way of doing this one-to-one mapping, which, like it says here, is quite exotic. I mean, we wouldn't normally think of doing a join table for a one-to-one mapping, right? There's no reason to do that, but we can, if we want. We can explicitly specify a join table for a one-to-one mapping. I'm actually going to skip that because it makes a whole lot more sense to do a join table for a one-to-many mapping. So let's go down here. So here's our example. Let's say that, all right, this is great. We have a trainer of monkeys. All right. And I love this. So it's a one-to-many mapping, right? A trainer can train multiple monkeys. I feel really awkward talking about this. I guess I shouldn't. But anyway, so we can specify a join table. Now the join table, we noticed in our database schema, the one when we just said one-to-many and didn't specify anything, we got a join table, right? We got that weird company underscore office, yeah. So we got a join table, and that's okay for now. What we decided was we wanted to specify the names of the columns. And so here's an example of how you would do that. You would say the join column, and you can actually join on multiple columns, right? I can have multiple join columns. But let's say we just do one. So we specify a join column. And this is the way that we're going to do it in our code. Right? Since we want to control the names of these columns, this is how we're going to do it. We're going to say join columns. Okay, so trainer ID, that's the owning side. And the inverse join columns, monkey ID, that's going to be the non-owning side, right? And this is how it works. So this is going to be a quick assignment for you guys. Basically, take a look at this and apply it for our database schema for our one-to-many mapping. Okay. This should just take you a minute. It's basically just copy and paste from here.
In this one, trainer ID is in trained monkeys table and monkey ID in the trained.
So trainer ID should reference so we're declaring that there's going to be a table called trained monkeys, right? It's going to contain two columns, trainer ID and monkey ID. Trainer ID will reference the primary key of trainer. Monkey ID will reference the primary key of monkey.
So why is it called inverse join columns? Is it just a name?
Just a name, yeah. When we say join columns, it's like this is the owning side.
Like join column 1, join column 2, right?
Yeah. Yeah.
But here, inverse join column doesn't mean, the way you have shown mapping from passport to the customer.
Yes.
Does it have the same meaning here?
Not exactly. It's sort of, because it's like the monkey isn't the owner of the trainer is the owner of the monkey. Right?
So how? Sorry. Go.
No, I was done.
How would you?
I mean, I was just sitting here feeling
map
awkward.
that monkey ID to be actually the foreign key, incoming foreign key from the monkey.
From the
table?
monkey table. That's exactly what this means. The inverse join table it says that this monkey ID is the primary key of the monkey table.
Okay.
Right. Trainer ID.
No, the inverse join columns, is that a standard name?
Yes. Yeah. Yeah. The join table annotation. Right. These are standard JPA annotations. Right. So join table annotation takes a few different fields. Name. We don't even have to specify a name. But join columns and inverse join columns, those are important. So that's your assignment of the moment. I'll just give you a minute
Which
to.
path do we achieve with inverse join column? Which path do we achieve? Because with the join column from the trainer table to trained monkeys table, that's a joining column.
So again, what does a join table look like?
One column we are looking as a common one. So in the trainer
No.
you have the trainer ID, and also in the trained monkeys also you have the trainer ID that shows which trainer.
No, so a join table is slightly different, right? A join table is a third table, right? So we've got a table for trainers, a table for monkeys, and then a third table that references both.
Yeah.
So each row in that join table says that this trainer is associated with this monkey.
Yeah, it's like a view, right?
No, it's not like a view.
When you join two tables and create a view, it will have both entries.
I see.
Data from here and data from here.
You can create a view by joining if you're thinking about it that way. Yeah.
Yeah, so these columns are referring to that view, right? Trainer ID and monkey ID.
Again, nothing to do with views.
No, just analogy.
Well, basically, they're the definition of it. They're the things that's saying that like this trainer monkey pair is associated. Like this is us defining that. We're defining that relationship here.
What do we achieve here? Inverse join and giving the monkey ID. What do we get with that?
Well, all right. Let's go back. Just if you're a little bit confused about this, we already have like we created this one-to-many mapping already, and so we got a join table called company office, right?
Yeah.
Right. So the company office table has a company ID and it has an office's ID. We also say that this pair, company ID and office's ID, is going to be sort of the primary key for and since this is one-to-many, not many-to-many, we can say that the offices are unique, right? Okay. So the only thing that I don't like about this join table is just the names of the columns. So really, this exercise is very simple. is just to specify the names of the columns to be what we want, right? So company IDs, since we declared the relationship in the company class, company is the join column, and offices is the inverse, right? Company is the owner, offices is the subordinate. All right, so while we were talking, probably had enough time to actually do it. So let's go back to where was it? Company? Yeah. Talked about it so many times, but I'm like, one of many. Okay, so join table. Join table. So, again, there's a few different things that you can specify here. We could actually set the name of the table explicitly, but I don't care. I think the name of it is fine already. So we'll just say that the join columns is equal to, have you guys seen this before? Annotations inside annotations. Yeah. Join column. Company ID. Office ID. So that should be okay. Let's oh wow. Huh. My auto format really likes them on one line, so I guess I'll put them on one line. Here we go, stop, go. Train.db.log. Here we go. Okay. All right. So problem solved, right? We've got a company ID and an office ID. Really, all that we did here was we just changed some names, right? So no big deal. If we had wanted, though, to specify some additional constraints for that join, I mean, we don't have anything in our current schema that would really even make sense, but we could do that here. We could have multiple join columns. Right. All right. I'm going to check this in just so that it's checked in, but immediately after I do that, we're going to blow it away because I want to show you sort of probably the more correct, like database-wise, what would be sort of the more correct and more efficient schema for this. So let's check this in. All right. So that's fine, but all right. Last thing that we're going to do is figure out why do we have this join table in the first place. Right? We don't actually need a join table for one-to-many mappings. Why don't we? How could we have represented this otherwise? Right? If our association is a single company can have multiple offices, how could we represent that in the database without using a join table? And also without worrying about like what kind of queries we might end up doing. Like don't worry about that for a moment.
By having the company's foreign key as a column in the
as a column in the office table, yeah. Yeah, so the office will then be the owner side of the relationship. We're flipping it around. Right now we say that, well, sort of in our objects, in our class structure, we're saying that the company is the owning side of the relationship. But I mean, we can't have like this isn't NoSQL, this isn't MongoDB or something, so we can't have a list of offices. So the next best thing that Hibernate decides to do is just create this join table. If we say that the owning side of the relationship isn't the company, but instead is the office, then it makes perfect sense.
How are you defining this owning side?
This is just sort of terminology, right? Like if we put it here, and declare this relationship here, we say that this is the owner, right? Yeah. Well, let's say instead that maybe, let's think about it in terms of the schema that we want. Let's do this. Let's do this. Where my schema keeps disappearing. Company, office. Okay, here we go. Let's open this up over here. Need to make this a little bit smaller, I guess. We don't need contact. Yeah, all right. So we've got company office, and we've got office. But company office is totally not necessary, right? If we know that each office will be associated with a company, we can just say office ID big int and do away with that table entirely. We would then say office ID is a foreign key into the company table, right? Or I'm sorry, company ID. Yeah, sorry. Thank you. Yeah, it's definitely well past that point of the day where I start talking gibberish. So I'm glad I've been doing well enough so far. Right, company ID. Yeah. So office will have a company ID. It's a foreign key into the company table, and that's a one-to-many mapping, right? Well, if we look at it this way, it's a many-to-one mapping. Many offices can refer to the same company. Right? Yeah, many offices can refer to the same company. That's fine, right? So in terms of query performance or whatever, what would it be like to search then for offices that set, basically, let's say I want to get all the offices for a given company. What do I need my database to do if it were a good database?
It's a join.
It's a join, yeah, and then
Index by company ID.
basically what's the performance of the join?
The number of offices. So it's
Depends on how many. Depends on how you join. The index should be company ID.
Yeah, we ideally we would have an index on company ID. Yeah.
So
Yeah.
that's what your query is going to be generated.
Yeah. So hopefully our database will be optimized for that. I think when we actually write the Hibernate or the JPA annotations for this, we won't actually see any like index, like generate index on this. But we can see. Basically, I think it won't be totally optimized, but we'll see what we get anyway. So what does this end up looking like? We said that we're trying to change. Here, let me close all this crap up again.
Is there a way to in Hibernate
To create indices?
Yeah.
I believe
Or optimize
so.
in certain ways, basically.
The answer is sort of. Yeah. All right, let's finish this up. So I need company and office. All right. So we're going to do something slightly different, right? Instead of the company having a one-to-many mapping, like being the owning side of this mapping, having a join table and all that stuff, we'll say that one-to-many mapped by, company, yes. Yeah, mapped by company, meaning that the Yeah, that the company property in the office table is what we're going to pay attention to here. Yeah, this is always a little bit mind-bending. Like, I always have to think about, like, what does mapped by mean? So, mapped by company.
No, in the office.
And in Office, yeah, in Office, what we're going to have is a many-to-one private company. Yeah. Since we have this here, and this is the owning side of the relationship now, we need to do our usual getters and setters. Right, we always need to do that stuff. So this is how we would do this, right? We would say that many companies might, or sorry, many offices might have the same company.
Why do you have mapped by in the company again? Company. So you don't want that constraint to be there
We don't want this to actually like show up in the database,
in the database.
right? We want to be able to reference it like this, but we don't want any columns to be created or any join tables or anything like that.
Mapped by company. Okay. Go to the office table again. Okay.
Right. So this, obviously, the inverse of a many-to-one is a one-to-many, and vice versa, right? So this is what this ends up looking like. Let's run this again and look at the database schema, and then hopefully, if it makes enough sense, then we'll like go home. I guess we'll talk about many-to-many briefly as well. All right, here we go. Training DB. Here we go. All right, we can see there's no join tables anymore, right? So we've got address, company, contact, office, and person. So that corresponds to all of our actual entities. We don't have any join tables anymore. Office has a company ID. And you can see that, so I mean, HSQL, since HSQL is an in-memory database, like there isn't like a index on the like create index on this column and that kind of stuff. I believe if we were working with Oracle, Hibernate would be smart enough to figure this out, or Oracle or MySQL or some like real database. But so it's simple enough for now. Okay. That's basically it. So just like a little bit of Hibernate magic again.
Just it puts a constraint, right? An office constraint.
Yes, I'm sorry. There are two constraints on Office, right? Company ID references company, and address ID references address.
Can you remove the map by and just show the difference in the DB?
Sure.
Let's save the DB logs.
Oh, okay. All right. We can do that. Let's run this again. Now it's going to be really weird. It'll create the table as well. Yeah. So we've got company office with so it's created the join table again. And the office table also has the company ID. Yeah.
Why did it do one to thing? I expected it to do the
Because we specified a one-to-many mapping here.
Yeah.
We also specified the many-to-one mapping on the other side. And we haven't said that. Basically, we haven't said, hey, don't make these redundant things. That's what this mapped by is all about. Is saying, hey, don't make redundant stuff. It says the other side of the relationship is already there. So just use that, right? So that's basically the right way to do this. Okay, I'm going to check this in. All right. So really, I think like that's basically what I wanted to cover at this point. We can talk. Actually, let's just talk really briefly about many-to-many.
One more quick question. How do you decide
yeah.
which one to use? One to many or many to one?
Oh, good question. I think so. So since well, let's go back to the doc here. There's a number of ways of doing one-to-many relationships, right? Bidirectional, right? So we want to talk about the directionality of the relationship, right? Like usually, I want to get from a company to its list of offices, and from an office to a company, right? It makes sense to be able to go both ways as efficiently as one another. So bidirectional relationship makes sense, right? So this is an example of that, right? One to many, many to one. This is the bidirectional thing. There is a well.
But if you're making it bidirectional, it always makes sense to have mapped by, right?
Yes. Yeah. There's a way here that sort of doesn't make sense to do it, which is unidirectional, using a foreign key column in the. I'm not sure why it's saying owned entity, but.
This is unidirectional.
Yeah. Wait, why does it say?
I think because on the ticket class they haven't created this map or anything.
Yeah, they haven't.
That side might be.
But this, like.
That's just to change the name, right?
Like, I don't even know, to be totally honest with you guys, I don't even know what this would look like in the database schema.
What?
So a customer can contain multiple tickets, but we're not going to have a join table. We're just going to have a join column. And we say, it's on the join column is on customer ID. So this is a strange way of expressing it. Yeah, so I understand what's going on now. This is going to give us the same database schema as what we did before. The schema like the bidirectional one, not with the join table, the bidirectional one. Yeah, but
no, this won't be bidirectional, right?
it'll give us the same database schema as if we had done the bidirectional thing, but we won't be able to access it from both directions. So this is a really weird way of doing it.
To me, it seems that it's going to create a join table.
It'll create a join table, right? No?
No. Notice what the name of this join column is. Customer ID. But we're inside the customer class.
No, just the name, right? You can put any name you want.
Oh, you can put any name you want. But this join column is going to be on the ticket table, which, again, this is what we have. This is what we have in our schema. The weird thing about it is that it's listed to get tickets here.
The ticket table would have customer and the customer would have ticket ID.
The customer table, the ticket table will have a customer ID.
Yeah.
The customer table will have nothing.
Yeah,
Which again is the schema that we have presently.
Oh.
The strange thing about it is that we've specified it as a one-to-many mapping on the customer, even though the join column is on the ticket. That's the strange thing about it. So this would be like doing the thing that we just did, except without the benefit of bidirectionality. Like it would make much more sense to just have it bidirectional, if we were going to do this. The default thing that it did, it was what we saw initially, right? This thing with the join table. Yeah.
If we can go back to
This one, this weird one.
Yeah, so that's how we did it for the company class before we tried many to one when we were working on one to many. That's what we did, right? On the
Well, we didn't.
company class, we had set of offices,
Mhm.
and that's where we said John column name equals company ID.
No, we had a join table.
Oh,
We had a whole join table, right, where we specified
oh,
the join like the join column and the inverse join column.
yeah,
Yeah.
oh,
Yeah, it's a little bit confusing because that join column annotation is used in both places. Yeah, so that's a good point. All right. So, so let's talk about many-to-many now. Is there, in a many-to-many relationship, is there any way to avoid having a join table? No. Yeah. Many-to-many relationship, neither one of those is going to have a uniqueness, right? Right. So in a many-to-many mapping, we need to have a join table. So that's why I wanted to show you this join table thing, because it works out to be exactly the same, right? Many-to-many with a join table. It's specifying some additional stuff here we don't really care about. We've got our cascade type and all that kind of stuff. But same deal, right? Join table. And then, let's see. So this is an employer-employee relationship. I guess that's interesting. An employee can be employed by multiple employers at the same time. Normally you would expect a non-compete agreement, but I don't know. I guess I could have multiple jobs. For all you know, I moonlight as a lounge singer. I don't know. That could happen. You probably don't want to see that, but yeah. So you can specify this, and this. So this is the inverse side of that relationship, right? We've got employer, which specifies many-to-many with a join table. Employee specifies many-to-many mapped by employees. Right, again, to avoid duplication. Yeah.
Otherwise, it would have created employee underscore employer and employer underscore employer.
Exactly. Yeah, it'll create two join tables. Yeah. Yeah. Very good guess. Yeah. All right. So we'll see. We'll probably see some more of this tomorrow. But that was essentially what I wanted to talk about. I wanted to leave today with our schema in pretty good shape. Now, what I said about sort of our agenda for tomorrow morning is, we're gonna start adding offices and stuff. Now, this is the first time that we'll see one-to-many mappings or many-to-one mappings, right? Like we haven't seen what happens when we deal with this in code. So although we've been basically copy and pasting our controllers so far, when we try to do the same thing, Hibernate is going to start throwing exceptions at us. It's going to complain about detached entities. It's going to complain about all kinds of stuff. So we'll see what it complains about tomorrow, and we'll see how to fix it. That's going to be the plan. All right. Any other questions on the more complex mappings and inverses? Did I totally just blind you all with science?
I had some other questions, but not related to that.
Okay, yeah, go ahead, please.
So, apart from this, what else is covered in the course?
Okay, let's go back to the outline here. Right, this I've been sort of adjusting this on the fly a little bit. Validation is going to be an important thing to cover. So we'll want, basically the example that I had here, for example, is like, let's say we've got employees and managers. That makes sense, and they probably should work for the same company. So we'll want to create annotations, or custom annotations that specify these constraints. So this is basically things that we can't represent as database constraints, we want to represent as constraints in code, and we want a nice way to do that. So validations is going to be important.
That is Hibernate or Spring?
Yes. Well, no, sorry, it's not Hibernate. It's Spring and Hibernate implements the validator. Sorry, I'm confusing the crap out of you. It's standard J2E, but of course Spring and Hibernate are both playing into it. So we'll see how that works.
So you're gonna touch upon the aspect-oriented programming side of Spring?
Not really, no. The only area where we really touch on that is our JPA repository, where it just sort of like generates code for us.
I'm sorry, what was the question?
Are we going to touch on aspect-oriented programming? Yeah, no.
I thought that's like a critical component of Spring, right?
It's just not that well covered in the course. And then
Advanced course cover it?
the advanced Spring, I don't actually teach that one, so I don't know. Like I'm not even sure that Maracana is the training provider for that. I don't know. It'll be a weird continuity thing for you guys. Find out. Basically, probably the most important thing before we even get into validation is understanding transaction. Right. So here, transactions. We're gonna see what happens when we've got lazily loaded associations. Right. We saw this yesterday. The fetch type equals lazy. We're gonna run into some issues with that, so we're gonna need a new little gizmo called open session in view. I'm not even sure what to call it. So some people call it a design pattern, but I think that gives design patterns a bad name. So this is going to be sort of miscellaneous stuff, and then sort of the rest of the day is going to be talking about Jackson and basically Jackson Spring integration and REST services. Day 5. To be honest, I don't know. We'll see what we're feeling like.
Is there an integration between Spring and JXB?
Yes. JAXB is terrible. Don't use it.
Why do you say so? I see like a lot of religious debate going on between. Actually, like some people say.
Okay. JAXB is terrible in the same way that Hibernate annotations are terrible, which is to say that you can't have immutable classes. Right. I really want my classes to not have setters and stuff, and like I'd really like to have final fields, just final fields in my objects. JAXB doesn't allow that. JAXB you need setters. Jackson, on the other hand, which is essentially a non-standard computing technology, that's what we're going to see tomorrow, you can have immutable classes, and so again, it's a much more sort of pure functional style of programming.
So what is the other alternative of JXB?
Jackson.
Jackson?
Yeah.
It also allows working with XML?
As of 2.0, it does actually.
Oh, it does?
Yeah. I won't be showing that, but yes.
So it's like a schema-based thing or non-schema-based?
Non-schema based. Similar idea to JAXB. You annotate properties on your objects, right?
But I mean, JAXB is more oriented towards schemas, right?
It's more oriented towards XML, and it can.
Schema-driven XML. Because then you compile the schema and generate classes.
You can do it either way. You can do it either way.
No, yeah, but what you are saying is the other way around, right?
But yeah.
You
What
have to annotate them, and then from that side you go. So
you would generate a schema from the classes, yeah.
You start with
Why
Java,
can't you have
then
immutable
Java.
classes in Hibernate? Anyhow, it's going to do reflection, right? Whether you have setters or not doesn't really matter.
Just the JPA standard doesn't allow for it. Technically, it would be possible.
Yeah.
Technically, I mean,
He's giving you the entire
should be
class
able to do
object,
it.
right? You can do anything.
yeah, but yeah, unfortunately, it just doesn't work that way. Okay, so that's basically from now on, it's just sort of tying up loose ends. The important stuff is going to be in the morning tomorrow. So the open session in view, how to deal with lazy loading, what happens if we've got detached entities, transactions, and that kind of stuff. And then from the afternoon on, will just sort of be fun stuff, just random other fun topics. But we're essentially coming towards the end of the meat of the course, right? This is like the important stuff that we needed to talk about. We're almost done with. Okay.
You want to talk about inverse, right?
We did.
Inverse. There's an inverse keyword. Right?
It's not an inverse keyword. I mean, it's just we saw that we can have a one-to-many mapping, and the inverse side was the many-to-one. So that's what we meant by that, or the owning and the non-owning side. All right, guys.
Hibernate annotation, right in the XML